Okay. Our next talk has the interesting title, Fuzzing the Corporate World. You probably want to...
Yeah, in a few minutes. Setting things up.
Okay. The next speaker is Gadi Evran, who works for the security vendor Beyond Security, which is based in Virginia, USA. So he is going to talk about things he knows about, because, well, fuzzing the corporate world just means, well, just put random data on some ports you find. This is great fun, as I can report from my own experience. So if you give a talk, be sure to have your Bluetooth dongle handy and have a tiny little program that just looks for cell phones and then fuzz them, which significantly reduces the annoyance of people just having cell phones ringing while you're giving your talk, which is always annoying. So this is again a call for people with cell phones in the audience to turn off their cell phones. Thank you. Okay, our speaker is an offender here, as we see. He has two cell phones.
Well, one for abroad, one that's roaming. So.
I see. So anyway, Gadi has also experience with the governmental world. He at some point worked for the Israeli government as a security officer, if that's the correct job designation. And then... Well, that's scary. Anyway, if you're ready, I'll give you the mic.
Thank you, thank you. You actually gave a biography, that's cool. Okay, before I go to the presentation and link the laptop, I want to waste about 2 or 3 minutes to talk about fuzzing, because this lecture is not really about fuzzing. The technological parts, I think there was also a presentation by Ilya about fuzzing yesterday, maybe? About the technology itself and how it works, and my purpose is not to tell everybody yet again how to do fuzzing and what types of input to send. Well, I'm actually going to do that anyway, but in general, that's not my purpose. My purpose is double. One, to show how organizations actually use fuzzing, whether it was 5 years ago and whether it's today, and to highlight the changes in fuzzing over the past few years that have made it fuzzing, that is, a part of some organizations or some corporations actually do fuzzing today, and the organizations that don't do fuzzing, why do they use fuzzing, what do they use fuzzing for, why do they need it, and what they ask their vendors to provide for them. So, 2 or 3 minutes, bear with me. What is fuzzing? I'll just pick somebody arbitrarily unless somebody speaks up, so. Okay, you, doing your email. What is fuzzing?
Sending random data?
Here you go. I'm setting up my laptop, it's cool.
Okay. Sending random data to some port and show what the service is doing.
That was quick. Okay. Sending random data into ports and seeing what the server is doing, meaning that the only thing I can actually fuzz is a network service?
No, you can fuzz. You can fuzz things like browsers.
Like what?
Browsers, web browsers.
Sorry. Okay.
Keep on the interview.
So you can fuzz browsers. Are browsers and network services the only things on the planet that actually take input?
No.
Okay, pass it over to... Yeah, thank you. Thank you very much for your kind contributions on fuzzing. Now, what else can we fuzz? What else takes input?
Yeah, anything, any program takes input because it's...
Any program takes input?
Yeah, most.
Hello World takes in. Well, actually, hold on now.
Okay, can somebody name a few who doesn't take input? Just
Hello,
output?
hello World. I'm serious here. Hold on, can you pass the microphone?
I mean, Hello World takes it.
First of all, name.
Shane. Hello World has input. You have environment variables. You've got limits on resources. You know, memory and the output goes to special places. So there's all kinds of ways you can manipulate the environment that Hello World runs in. So I would agree that any program does have input for sufficiently convoluted definition of input.
I'll go for that, but this is when I stop the discussion, not just because my laptop is ready. That is just, woo! Hold on. No? The wonders of function F5. Okay. Not just because every program in some way takes input, or should we say is dependent on some environmental inputs that we can somehow play with, manipulate, or modify. Isn't that the same thing? But because we use programmable computers. We use computers that are for more than one purpose. Nearly everybody in this room, except for me, has some sort of single-purpose computer on them. Does anybody have any idea what they are? Single-purpose computers in this room. Nearly everybody has them. That's correct. The watch. Okay, the microphone, yeah, okay. I think that there's actually nothing smart in the microphone. It's just purely, no? Oh, you want to give the microphone to somebody. You're not giving the
There's
microphone.
crypto in here, so make no mistake, there's a single-purpose computer in here.
Other than the watch. No? A cell phone might be. Take the mic?
Yeah.
The microphone?
Oh, yeah. I was saying, well, cell phones, although nowadays a cell phone is getting more and more like a programmable computer, but original cell phones could be considered as a single-purpose computer, I guess.
No. And not because I'm annoying, I am, but because, seriously, I don't really believe that other than the very, very original cell phone when they tried to redo Star Trek, was anything but, I mean, today, can you actually name many devices in the world that don't have some sort of software on them that you can download and modify?
Well, electronic devices, I wouldn't say many, no.
Even this thing has software on it that I can modify.
Yeah.
Right? So,
Yeah, totally.
well, not to, I mean, I'm beating around the bush. Basically, the main problem we have security issues other than design is because we have the programmable computers. Now, that's why I'm repeating this is for the very simple reason that fuzzing is, if we have to simplify it, and we are going to define it in a second, it's a testing technique. And not just a testing technique, it's a black box testing techniques, that means basically we have no source code. We have no, I mean, in theory, have no actual data on the software or any previous hints of what the implementation looks like. Okay? Now, I don't believe that definition. If we read this Wikipedia definition for a second, fuzz testing or fuzzing is a software testing technique. As you see, I copy-pasted, and it kept the HTML. Is a software testing technique. The basic idea is to attach the inputs of a program to a source of random data, fuzz. If the program fails, for example, by crashing or by failing a built-in code assertions, then there are defects to correct. Wow. Okay. I disagree. Can anybody tell me why? Nope. Well, what this guy said, actually, what's your name? What? Christoph, okay. What this guy said was basically take input, throw it at a program or a service, as they put it, and see how it reacts. I believe that defines black box testing much, much better than just attach some sort of input to a program. So first of all, we assume it's a program. Source of random data, I don't agree that it's random data. and see if it fails. I don't agree if programs should fail. It's not always by crashing or failing built-in code assertions, and this is where we're going to actually start going over how corporations can take all this and use it, because so far, to be honest, what have we had in the fuzzing world? I mean, in the late 80s and mid-90s, we have had Bart from a university in the States, as I forgot the name, Barton Miller, who took pretty much random data, attached it to programs, and crashed them. And that was pretty cool. But most fuzzing tools that came afterwards, I won't say that weren't very good, but were amateurish in the fashion that they were unbuilt. Meaning, if I build a fuzzer, it's for me. And I'm the one that was going to use it. I didn't expect for that fuzzer to actually be used by anyone who doesn't know what code looks like, who won't be able to tell if a function should end somewhere where it even begins. And the whole idea of corporate fuzzing is, in most cases, again, there are different areas where that can actually be attributed. The whole idea is they don't want to look at source code. They want to use fuzzing today as a sort of tool to help them mitigate, eradicate, terminate, whatever you want to call it, bugs in software. I mean, I'm not sure what everybody here does, but the security people, we keep getting pissed off at software vendors for saying, how the heck can these guys still have this basic Stack Overflow in their software? I mean, do they even do any type of input validation, not to mention proper input validation on their software? And the answer is usually no. But that did not change that fact until we could provide these corporations with some sort of tool to say, hey, if you use this, you'll get rid of most buffer overflows. Now, I'm not saying that you'll get rid of all buffer overflows or of all bugs whatsoever, but you will definitely get there by eliminating most of the simpler bugs or vulnerabilities and moving on. And the whole point is they're pointy-headed, like this lecture. If anybody expected a technical fuzzing lecture, then I apologize, and I would forgive you if you get up and leave right now. The point of this lecture is how fuzzing actually gets into the corporation and how they use it. So let's move on now that I wasted 5 or 10 minutes. So random input, right? I disagreed with that statement because, in my opinion, random input, as useful as it might be, is long gone. Today, for any fuzzing to make, I mean, you can still find a lot of vulnerabilities and a lot of bugs, but just sending and some sort of random input at the program and seeing what happens, that's true. But it can be a lot smarter than that. And then we go to sensible input, which means, hey, let's look at what the program expects to see, or what we might expect to send a program, and use that instead. Then we move to block-based input, which basically Dave Aitel introduced a few years ago, which says, hey, let's send requests that the program will know I'm generalizing here, but let's send requests that the program would know to expect, such as if we use HTTP, we'll send get file.name HTTP 1.0 whatever, and end the request, and pick some location in that string, say the extension of the file name, and fuzz that area or other areas. We can also call this value manipulation in a way. It did not really teach the fuzzer the protocol. It did not really teach the fuzzer everything that it needs to know if it is to be a smart fuzzer, as people call it today, but it was a step in the right direction. And protocol-based input is basically, hey, and I chose these names. They're not necessarily representative of what people actually talk about. Protocol-based input would actually mean, hey, let's teach the fuzzer. Let's train the fuzzer. Let's make sure this fuzzer knows what it's talking about. So when it sends a GET request, it will also know what POST is. Okay, again, we choose HTTP as what we want to test or fuzz. Kind of boring nowadays, but still. And we want to be able, for example, if we use FTP, to tell the fuzzer, depending on the purpose of the fuzzer, don't just try and fuzz the username and password. Try to be a little bit smarter than that. Once we establish the protocol, we can establish a session. And FTP does require sessions, or stateful, or whatever else you want to call it. And basically, hey, we send the username. Let's send the username yet again, see what happens. Or we sent this